Hi, I'm Miss Hearn. Let's get started. We have an application question which involves a quadratic. It says the population P of a culture of bacteria is given by P equals negative 1490 T squared plus 60,000 T plus 30,000, where T is the time in hours since the culture was started. Determine the times at which the population was 600,000. Round to the nearest hour. We're given a formula relating the population to the time t, and we're told that when p is 600,000, we want to find t. So we must plug into the equation, giving us 600,000 equals negative 1490 t squared plus 60,000 t plus 30,000. We know this is a quadratic equation because the highest power on the variable is a 2. So we're going to go ahead and get it into standard form, which means 0 on one side. So you can either subtract 600,000 or you can bring everything else over to the left. I'm going to go ahead and do that because I like to have a leading coefficient that's positive. So I'm going to say 1490 t squared, adding that over to the left, and we're going to have minus 60,000 t, and then subtracting 30,000, we're going to have plus 570,000 equals 0. Now we could use factoring, but factoring really isn't reasonable for solving this quadratic equation because it's not immediately obvious and it would take a really long time to find out whether or not it even factors. So we're not going to do that. It doesn't fit the pattern for the square root property, and it would only fit the pattern for the square root property if we used a process called completing the square. I like to leave completing the square for certain specific situations where it's absolutely necessary because most people prefer to use the quadratic formula, and that's what we're going to do. So let's go ahead and remember what our quadratic formula says. It says when we have something of the form at squared plus bt plus c equals 0, t will always be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Identifying a, b, and c is pretty straightforward. A is going to be the coefficient then of t squared, so a is 1490. B is going to be negative 60,000, make sure to include your sign, and c is going to be 570,000. Most of my students are okay up to this point, and then it's plugging into the calculator that usually causes a problem. So we're going to go over that really quickly. Plugging in, we have t equals the opposite of b. B is negative 60,000. The opposite of that would be positive 60,000 plus or minus the square root of b squared, so negative 60,000 squared minus 4 times a, which is 1490, times c, which is 570,000. Watch all those zeros there. Over 2 times 1490. Now we're going to pull out our calculator. And the challenge that we face here is the order of operations. So remember, order of operations, we work inside the grouping symbol first. That's the P in PEMDAS. E stands for exponents, come next, then multiplication and division, and then addition and subtraction. So working inside of this grouping symbol, the radical, we are going to have 60,000 squared, and then we're going to subtract from that. And now I'm going to put in parentheses because I want the calculator to know that I have to do the multiplication before the subtraction. 4 times 1490 times 570,000, close parentheses. Now I'm going to hit equals to get what's under the radical there. Equals 202,800,000. Now I need to take the square root of that number. So I'm going to type in 202,800,000 and take the square root. That is going to give me 14,240. So it's 14,240.8 is what we get instead of this big radical here. We now have two answers that we need to find. 60,000 plus 14,240.8 over 1490 times 2 is going to be 2,980. And then I also need to find 60,000 minus 14,240.8 divided by 2,980. So 60,000 plus 14,240.8 equals 74,240.8, but we're going to now divide that by 2,980, and that gives us about 24.9. Now I want to show that to you one slightly different way, which is instead of hitting the plus and then equals, I could have told the calculator that this fraction bar is acting as a grouping symbol by putting parentheses 60,000 plus 14,240.8 close parentheses. Now the calculator has done what's in the parentheses first, then hit divided by 2,980, and I should get the same answer. Yeah. Okay, so now let's do the minus version. So we have 60,000 minus 14,240.8 equals, because I need to make sure that the calculator doesn't think I just wanted to divide the second value by the 2,980, divided by 2,980 equals, and we're going to get 15.4. Now, I also want to point out that the reason why I went ahead and I rounded this off to a decimal place is because the instructions told me we were going to be rounding. So that's going to depend on the problem that you're working. In this case, we get 25 hours if we round to the nearest whole hour, and this one's going to round to 15 hours. So there are actually two times at which we have a population of 600,000. I hope you found this video helpful. If you did, please remember to like it.